Okay. So we're going to set up a little collision detection example here, but we're not doing we're doing a very like a simplified version of collision detection. It's not exactly quite collision detection yet. So we're just going to call this simple collision detection. And the reason this is simple is because we're just going to compare the position of 2 points rather than the actual size of the shapes. But you'll see what I mean in a moment. So let's put the date, and then I'm going to draw out a little bit of how this is going to work. So on your computer, and pretty much in any program, whether it's a video game or a website or anything else, one of the main things that we have to do is detect if two things are colliding. That means they're in the same space. So when I move my mouse around on the computer, you can see all sorts of stuff will change or react as my mouse moves around. My tabs highlight, different parts of the P5 interface highlight. I can select things. The computer is always tracking where the mouse is, and we can use code to figure out if the mouse is touching something or pointing towards something or clicking on something, and then we make decisions based on that event. And so we're going to program a very simple version of that event right now that we can use in our game. So the basic idea, the way that we do this is everything has exists in space somewhere. And we're just going to start with 2 points. So in our game, we have our little character down here. And the character has a point where it draws from. This is the XY position. We have that in our code. We have let x equals and let y equals. And we track that as the game updates. So we always know where the character is. Then we have like a little bird. And the bird has its own XY position. So just like in Scratch, how all of our sprites have an XY position, what Scratch does is it takes the XY position of our sprites, but it also looks at the size of the image that we're using for the sprite to determine if they're touching. But this is very blunt, meaning that it can't really change that basic setup. And we can't program Scratch to do anything differently. In P5, we can program it to work however we want to, but we do have to tell it how to work. So what we want to do is we want to know if these 2 points are close enough together. So if our character and the bird are like right here, that means that, our character gets to eat the bird. So we need to know if the 2 points are close enough together to enable that event. And this is pretty easy to do using math. If we have 2 points in space like this, and we know the XY position of each one of those points, then we can determine the distance, which is this value here, d, using the Pythagorean theorem, which is just a squared plus b squared equals c squared. But don't worry, we don't actually have to do that. We can just use code to do it for us. So there's a built-in function in P5 called dist, which will take 2 points, 1, 2, and it'll give us this value. It'll give us that distance. So then we just decide how big we want the collision to be, and we compare the distance here to the collision. So let's say our character is 50 pixels wide. That means if the center is here and the character is 50 pixels wide, then half the character might be like 25 pixels. And so we can use that as kind of like the radius of that circle as our distance that we're comparing to. So we can say if this distance here is less than this distance, then a collision has occurred. This is a very simple version because we're not taking into account the actual size of the shapes. Like the bird might be really big, it might be really small. All we're taking into account is the position of the 2 points and then the distance in between the two. But that'll be good enough for us to get started with our game. So let's see what this looks like in code. So let's imagine that we have 2 points. We'll say x equals 200, and we'll say y equals 100. And then let's draw a circle at that point. So we'll draw a circle, at x, y, and let's make the circle 50 pixels wide. So we've got this circle, and now what we need to do is figure out if our mouse is inside the circle. So we can easily get the distance between the mouse and the circle by using that formula. Let's also draw a line between x, y, and mouse x, mouse y to visualize that. So we can see this line, and as I move the mouse around, you can see sometimes the mouse is inside the circle and the line is pretty short, right? No matter what direction I'm in, since it's a circle, if the mouse is inside the circle, that line is going to be pretty short. If the line is very long, that means we're outside of the circle. Again, because it's a circle, there's the same distance on all sides from the middle. So all we have to do is figure out how long that line is, and we'll know if the mouse is inside the circle or not. So let's do that calculation. So in P5, we have the distance function, and we can look this up in the reference. So it's just called dist for short. And it calculates the distance between 2 points. And so we just have to give it 2 points, x1, y1, x2, y2, and it'll tell us what that distance is. So we don't have to do the math. P5 is going to do the math for us. So let's make a new variable. We're just going to call it d for distance. And we're going to calculate the distance between the x and y of our circle, x, y, and mouse x, mouse y, the changing mouse position. And for now, let's print that on the screen. So I'm just going to say text is d for distance at, I'll put it up in the corner. Okay, so you can see that distance there. I'll make it a little larger. So I'll make the font size like 40. Or text size. Okay. So you can see the distance when we're far away. It doesn't matter what direction we're in. So the distance over here is 187, and the distance over here is 180 something, the distance down here. It's just calculating the absolute distance. So it doesn't matter if we're going up or down or left or right. We're just getting the distance between those 2 points. So whatever the length of that line is. And if we're inside the circle, that distance is going to be low. Since the circle is 50 pixels wide, the radius of the circle is 25. So we can detect if we are inside that circle. So let's give the circle size a value. Let's say let radius equals, and we'll say it's 25. So now we can use that number to determine both the size of the circle, how we draw it, but also how we do the calculation. So for the size of the circle, we want radius times 2. So remember, in math, the size of a circle is 2 times the radius. The radius is the distance from the center of the circle to the outside of the circle. Okay, so now we can check to see if the distance is greater than the radius. So let's make another variable, and let's call this variable is colliding. And we'll just set that and say is d less than radius. If that's true, then we are colliding. So all we're doing is we're taking this distance value that we just calculated, and we're comparing it to the radius. We're saying, is the distance less than the radius? And if that's true, we'll get the value true. If it's false, we'll get the value false. So let's look at that next. So we'll do text and is colliding. We actually haven't talked about text yet. We're going to do that next week when we set up a UI. So I'm going to say is colliding, and we'll put this a little bit farther down so we can see both of those values. Okay, so now you can see as long as the line is greater than 25, then the value is false. As soon as the line is lower than 25, you can see the value is true. Okay, and that's updating as we're drawing the sketch. So this simple formula just tells us if we're inside that circle or not. And then we can make other changes to the sketch based on whether or not this is true. So let's actually move all of this. Let's move our circle down here a little bit. And then let's say if is colliding, then let's make a fill that is green. And if it's not, so we'll say else, let's do a fill that is red. So now you can see the fill is red, and then if we move into the circle, the fill becomes green. It doesn't have to necessarily relate to the object. Like, we can change other things. So we could, change the whole background of the sketch. We could do other things. But this just tells us whether or not we are inside of this circle. So that's a very, very simple collision detection. Notice that since we're using our variables, if I change any of those values, the whole sketch will update to change. So let's say I want to move the Y down, so I move the Y down to 200. It still works exactly the same way because we're calculating these, we're making these calculations based on the numbers that are held in the variables, not on, just random numbers or hard-coded numbers. Okay, so that's the basic principle. I'm going to rename this simple collision detection, and I'm going to save it, and I'll add it to our collection. So we're going to implement this in our game next. Any questions on the basic collision detection before we move on to the game? Yeah, I'll share these, the code, once I'm done. So if you don't have every single line or character, you'll be able to look at it later. Any other questions? Okay. So I'll leave this open, but we're going to go to a new tab, and we're going to open up the game, and we'll implement this with our player and our bird. So I'm going to open up a new window, and I'm going to open the last version of the game, which is this add a bird object, where we introduced objects into our game. I'm going to make a copy of this so I won't overwrite what I wrote last week. So I'm going to go to File and go to Duplicate. And I'm going to change the name of this one to Collision. Adding collision between bird and player. It's kind of a long one, but that's okay. So let's update our comment at the top. Oh, I don't need two adding. Adding collision between bird and player. And we'll update the date. And I'm going to remove some of the comments from last time just to clean up the code a little bit. So I had a lot of comments for various notes as we were setting this up, but hopefully we understand how objects work now, more or less. And so we can get rid of some of these comments just to make the code a little bit simpler. Then I'm going to collapse these main functions so that it's a little bit easier to see everything. And there we go. So I have my player declaration here. I have my two bird variables. Then I have all of the variables that I use to hold the image data. And I have my preload function to load all of that image data. And I've got my setup function, which creates... There we go. This creates the canvas, and it creates my two birds. In the draw function, we move and display the player, and then we move and display both birds. And we're going to add our collision code in there now. And then our player and our bird function have a lot going on. Let's just take a look at one thing, which is we need to find a way to get the X and Y values out of the player and the bird, because that's what we're going to need to compare. So as our game is running, we're going to have our player down here, and we're going to have birds appearing and going down. And for the player to eat the bird, we need to make sure that the bird is like at least reasonably close to the player. And we can program this to be whatever we want, but we just want to detect when the bird is reasonably close to the player, and then we'll trigger the event, which where we'll change the art and we'll play a sound and we'll make it clear. We'll update the score. We'll make it clear to the player that they achieved the goal of eating the bird. And so the thing that we need to be able to do is calculate between bird and player the origin points of each object, and we need to get the distance of this line and then compare it to whatever we decide is the size of the player that we want to use. So we'll have to figure out a way to get the X and Y values out of those objects, and then we'll have to compare them. Okay, so let's set up our functions, or let's create a new function for our collision. So I'll put this down here after the bird. I'll just say function detect collision. So the purpose of this function is to compare the position of two objects and return true if they are colliding. So we're just going to compare where the two objects are on the canvas, and if they're close enough together, we're going to tell our main program in the draw function that they're colliding. So we're going to call these objects object A and object B. It doesn't actually really matter what the objects are, like which one comes first. All we need to know is if they're colliding. So we're going to compare object A and object B. So we get these two, we're going to put both of those objects into this function. We're going to do a little bit of math, and then we're going to tell the main program whether or not they're colliding. So now we need to be able to get the X and Y position from the player and from the bird. So we're going to have to modify both of those functions to get the X and Y values out. Yeah, let's do that first, and then we'll update our draw function. So let's start with the player. So we have let X and let Y here. And we know that because they're member variables, they're not available to the rest of the program, except for Avi's program. What do you have in there? A fish? Your fish has actually exposed its member variables by using the this keyword, and so you actually could write this differently, but I'm sure you already knew that. Yeah, okay, so our X and Y variables are not exposed, so we need to be able to let the rest of the program read those variables. And so we're going to create a new function. So we have the move and we have the display function for our player. And now we're going to make a new function called getPosition. And all this function does is it returns the X and Y values to the main program, or to whatever's accessing this function. So to return a value, we just use the keyword return. Just like we did down here, you're going to start to see a lot of the same patterns repeat. And we're just going to put the X and the Y values into a little object like that. So just like we return our functions from our player object, we can return values from a function. So remember, we also have to return getPosition to make it accessible to the rest of the program. So after move and display, we're gonna return get position. We are gonna do the exact same thing with the bird. So because the functions look pretty similar, we can just copy and paste this whole section and replace it in our bird object. So I'm gonna go to my bird object, and I'm just gonna replace this return statement with the new code. If you're worried about losing stuff, you could also just copy and paste and then remove this return function. Okay, so now both my bird gives access to its position, and my player also gives access to its position. Okay, so this is all the stuff we have to do since we're not using Scratch anymore. Scratch does all this stuff for us. So when we're writing our own code, we have to think through the way that we make these things accessible. Okay, so let's go back to our detect collision. So we need to get the position for our two objects. So I'm gonna make a new variable and say let position A is object A dot get position. There are shorter ways to write this stuff, but I just want to make this as clear as possible. So when we get object A, this is going to be either the player or the bird. We're going to use the get position method that we are returning down here. And that's going to give us the X and Y values of that specific object and not any other object. So then we can say let position B equal object B dot get position. And so now we've got the two positions, and we can just compare the two. We need to get the distance first. So we'll say let D for distance equals, and we'll use the dist function. So we'll say position A dot X and position A dot Y. It might actually make more sense to say a position because it's the thing that has the position. Anyway, that it doesn't really matter what you call it. Let's see, a position dot X. That kind of sounds better. I'm just gonna change these real quick. So a position dot X, a position dot Y. So we're getting the X, Y of our first object, and then we're getting the distance to the B position dot X and B position dot Y to the second object. And so when we return our X and Y, by putting them in a little object like this with our little curly braces, that makes them accessible based on the name of the variable. So we can just reference them by saying dot X. That's the same thing as when we say dot get position, and we have the get position up here. The only difference is when we're using a function, we have the parentheses. And when we're using a variable, we just say the name of the variable. So a variable is like let X or let Y. It's just a number or a piece of data. A function is like function move or function display. It's a piece of code that does something. Okay, so we've calculated our distance, and now let's decide if they're colliding. So we'll say let is colliding. And here we're going to compare the distance, and we're going to ask, is the distance less than some threshold that we want to compare? So here's where I want to maybe make a global variable, because otherwise I'm going to have to go back into this function and find where I made this every time I want to change this number. So it's going to be easier if I make a little variable up here so I can change that parameter instead. So let's call this collision radius, and then we'll go up to the top of our program and we'll say let collision radius equal 25. So we'll just use what we were using in the example. We can change this later if we want to. Okay, so is colliding is going to be equal to is D, the distance between the two positions, is that less than our collision radius? So now we're just going to return is colliding. Like we did in our previous example, we'll get a true or a false. So we'll say returns true or false based on that collision. Okay. So there's a lot of code, but we're almost there. So now let's detect our collisions in our draw function. So we're going to move and display the player, and we're going to do the same with the bird 1 and bird 2. And now let's detect the collision between the player and bird 1. So we're going to use the detect collision function. And then it doesn't matter which order we go in, because we're just comparing the two objects. So let's just start with the player, just to start with the player, and then we'll put in bird 1. So this is going to detect the collision for us, and it's going to give us a value that's either true or false. But to use that value, we have to save it in a new variable. So we'll say let what should we call this? Let bird 1 collide equal detect collision, because we still have two birds. We're gonna make this look better at some point, but for now we'll just say, so if bird 1 collide with the player, then this will tell us if that's the case. So for now, let's just log this to the console, and then we'll decide what to do with it in a moment. So we're gonna detect bird 1 collide. Okay. And we've got an error. Let's see what our error says. Detect collision is not defined. Okay, I probably spelled it wrong. Let's see. I'm just gonna copy and paste. Okay, I did spell it wrong. I'm not really sure what I missed.
An extra C after the E. You put D-E-C-T instead of...
Oh, I spelled the original one wrong. Okay, thank you. Let's get rid of that extra C. Okay, now let's try it. Okay, so we need to open the console. And so you can see, I'll move my player over to the side here. You can see it's just saying false a lot because I'm not colliding with the birds. And then if I get close to a bird, you might see a little true for a few frames. So you can see it's saying true here. And then the number of times it says true is basically how many frames are they colliding for. But we're also only detecting one of the birds. So one of the birds is just always going to be false. We're not going to fix that today. We'll fix that another time. Okay, so this seems to be working. We're at least getting a different value. And we are getting true some of the time. So let's decide. So we'll say if bird 1 collide. This is where we can decide what we want to do. So I'll put a note here, detect collision between bird 1 and player, and then react to collision event. Okay, so in Scratch, when we did this, if we ran into a bird, let's see where we handled that. We might have handled it in the bird. Here we go. So if we said if the bird is touching the player, we're going to switch from flying to dies. I don't see anything else here, so I must have put the rest in the player. Oh, here it is. So if touching the player, we play a sound, and then we broadcast that the bird is eaten, and then we spawn a new bird. So that's what we did in Scratch. In P5, we can do something similar, but we'll have to, write some code to do what we want. Okay, so we'll say if bird 1 collide, we're gonna have to do something with the player, and we're gonna have to do something with the bird. So let's say player.eat. We'll make up a function called eat. This doesn't exist yet, but we can just create it. So the player will eat the bird, and the bird will die. So we'll say bird.die. Doesn't really matter what you call these functions, but we want to make it clear what happens when this event occurs. Okay, so these functions don't exist, so if we try to run the code, we're going to get an error, although it seems to be going anyway. There we go. There's our error. Player.eat is not a function. So we've got to make those functions. So let's start with player. So we've got move, we got display, we've got get position. Now we need a new function called eat. So anytime we want a new functionality with our object, we can just throw in a new function. Okay, so what we want to do when we eat is really just change the animation to eat. So that's pretty easy. We just say animation state equals 2. So that's going to be our eat animation. But now we have to update our display function to include that. So right now we have if animation is 0, we draw the idle sprite. If animation is 1, we draw the walk sprite. And so we have a new condition, so we just add an else if. In P5, we can add as many conditions as we want, unlike Scratch, where we're kind of limited to just else, if, and else. So if animation state equals 2, then we're still going to draw an image, but this time we're going to draw the eat sprite. So I'll get char eat sprite and draw that at xy. We are going to run into an issue. Some of you may have already figured this out, which is that our move function is constantly setting the animation state back to 0 on each frame because we're assuming the player is idle. So we have to add in a little code here to basically say if the player is eating, we don't want to set it back to idle. So we can say if animation state equals 2, we don't want this to happen, so we can actually say not equals. Okay, so I'll put a little not equals here, and then I'll move this up here. So what this says is as long as the player is not eating, then assume that the player is idle. And then we'll leave, for now, our walk animation the same. We'll say that if the player starts eating a bird, but then the user or player keeps walking, then we do want to go back to the walk animation. This might not be the most sophisticated, but this will be good enough for now. So I'll put a note here that says if the player is not eating, then we assume the player is idle. Okay. Let's see if this much works. I'm going to comment out bird die for now so that we don't get an error there. Okay, so now one of the birds should make the player start eating. Oh, I got an error here. You might be able to guess what the error is. Any guesses why I got an error? Player.eat is not a function. So I have my function eat. Is there a reason why I can't access it? That's true. It's a member function of the object, so it's not accessible, it's not global. What do I need to do to make it accessible?
Move it outside of the function.
I could do that, but then it would just be a function that would make anything eat, or probably just not do anything. What else can I do to make it accessible? Any ideas? I'll give you a hint. The line of code we need to modify is on the screen right now.
Is it a return?
We need to return the eat function from the object. So we just need to add it to our return statement. So the return, let's put a note here actually. So return makes member functions, so functions that are part of the object, available to main program or to other parts of the program. Okay, so now we'll be able to eat the bird. We just have to figure out which one is the right one and get close enough to it. There we go. We're eating one of the birds, and now we just have to make the bird die. Okay, so this is the last bit. So besides player.eat, we have bird.die. So let's go to bird, and let's define a die function. And for now, this is going to be almost exactly the same as the player's die function, because all we're really doing is changing the animation. So for our bird, animation state 0 is when the bird is just flying or idle, and animation state 1 is when the bird gets eaten. So when the bird dies, we just are going to change animation state to 1. And then in display, we have to make sure that it does that. So we'll say, we'll just add here, else if animation state equals 1. And we'll still draw an image, but this time we're going to do bird eaten sprites. And we're going to draw that at XY. And then the bird resets when it hits the bottom. So for now, I'm not going to change anything there, but I am going to set the animation state back to 0 so that the bird is not, goes back to normal when they reset. So I'm just going to put this in here. Okay, so now this only works with one bird. Uh-oh, we got an error. Let's see what it says. Bird is not defined. Oh, you know what? I wrote bird instead of bird1. Okay, so we have bird1.die. Uh-oh, we've got another error. Bird1, oh, same thing. I forgot to return die. So let's return die along with move and display and get position. Okay, so now we can eat this one bird, but we can't eat the other bird because we didn't write that code yet. I'm going to leave it as is. If you guys want to put that in, you can, but we're also going to learn a better way to do that in a week or two. But there we go. Now we can detect the collision between the player and the bird, and we can change the animations based on that collision. And we have a little more control over this. So you can see we can look at where this collision is happening. So one last little thing, and then we'll stop. We know the radius of the collision, and so we can actually display. So one of the things you might do when you're designing a program is display different things that are happening that are not actually part of the regular game. Sort of like in Scratch when you make your variables visible. Like if I want to see what my variables are as I'm testing, I can turn the variables on. Sort of like how I drew the values in the screen here. So we can kind of give ourselves information about what's going on that's not going to be part of the final game. So what I want to see is where is that detection area actually happening. So what I'm going to do is go to my player, and I'm just going to adjust the display function a little bit. I'm going to go down here, and I'm going to write a note that says debugging the detection area. And I'm just going to draw a circle at the player's XY, and then I'm going to use this radius, the collision radius, times 2. Since it's the radius, 2 times the radius gives me the size of the circle. And so now I'm drawing a little circle, and this should correspond to when the bird gets eaten or not. So if the bird passes through that circle, if it's the right bird, it should get eaten. So this actually tells us a couple things about our program. What does it tell us about the program? Is there anything weird about where that circle is? Yeah. What? Right, it's not directly over the character's head. And this is for a reason that may be a little bit obscure. We have talked about this with our shapes, but in P5, remember when we draw a rectangle, not an arrow, but a rectangle, remember that a circle draws from the middle, a rectangle draws from the corner. And so that's why the circle is like here, but our character is here, because an image is a rectangle. So we can actually change this really easily by changing the image mode. So I'm going to go to setup, and I'm going to say image mode is center. So we haven't done that with the image mode. We did that with the rect mode at one point. Okay, now my circle matches my player exactly. Or not exactly, but pretty close. Let's change the display just a little bit. So I'm going to say no fill. Okay, so now I just have a circle that just shows that detection area. So that's pretty good, but you know, my player can eat a bird even if it's like barely touching its you know, the center of the player. So I may want to make that area smaller. So if I change the collision radius, let's say I make it like 10, notice that this updates, and then our collision will actually update as well because we used a variable there. So now I can test this and see if this feels better. I can try to eat the bird, although I still don't know which one is which. And it's still pretty doable. I can get the bird pretty easily. But if, you know, if it wasn't easy, I could make it bigger, or if it's too easy, I can make it smaller. I can kind of play around with what that looks like. And then once I get something that I like, I will just comment out this debugging. So I may want to be able to debug later, but generally that's not something I want in the final game. And now I'm going to test with debugging off and see if it's still doable. It's a little harder if I don't know exactly where the circle is, but I think it's still pretty doable. Okay. All right, so that's it for now. There's a lot of code, so you know, obviously I'll make this example available, and we'll try to implement this today. What we'll do in the second part of class is add some sound. So we'll add some music and some sound effects, just to kind of reinforce the event, but also add some more media into the game. So I'm gonna add this to the class collection, and I'll stop here.